Buenos dias. Here we are again, 1.4 prime factorization. We are going to have our goal today set as I can write the prime factorization of any whole number. Okay, so yesterday we started with a little introduction activity where we started talking about the idea of factors. Okay, so you see that hidden root word in the word factorization. Okay, we're talking about factors this week, which has a lot more to do with divisibility than it does multiples. So we're finding numbers that go into something. So let's talk about first what is a prime number. Okay, we've talked about that a little bit before. A prime number is a whole number greater than 1 with exactly 2 factors. Okay, notice that it says a whole number greater than 1. Okay, yesterday there was a few of our classes that we discussed that 1 we thought was a prime number, but 1 only has a single factor. It does not have 2 factors. Okay, so we have to make sure that we remember that in order for it to be a prime number, there has to be exactly 2 factors. Okay, let's talk about number 2, composite numbers. Okay, a composite number is a whole number greater than 1 with factors other than 1 and itself. Okay, we have talked about that before as well. Okay, that a composite number has more than 2 factors, or in other words, it has other factors other than 1 in itself. Okay, number 3, factor pairs. Okay, a factor pair is a set of 2 numbers which, when multiplied together, result in a definite number. Okay, for example, a factor pair would be like 2 and 4 is a factor pair of the number 8. Okay, a factor pair of the number 8. So 2 times 4 would make 8. So this is a factor pair. It's a set of factors that, when multiplied, make another definite number. Okay, number 4, prime factorization. Prime factorization is a number written as a product of its prime factors. Okay, so we will discuss that in these notes. It is a number written as a product of its prime factors. Okay, I want you to underline the word prime and factors. Okay, and I also want you to underline the word product. So that's kind of our key there. It is written as a product, which means the answer to a multiplication problem, of its prime factors. So in other words, the prime numbers of being multiplied together. Okay, and let's talk about a factor tree. A factor tree is a tool that breaks down any number into its prime factors. So we use a factor tree. Okay, we use a factor tree. I'm going to circle that one. We use a factor tree in order to find the prime factorization. Okay, prime factorization steps. Okay, so we have 3 steps here in order to find the prime factorization of any whole number. Okay, first is that you need to find a factor pair and draw branches. Okay, secondly, we are going to circle the prime factors as you find them. And then thirdly, we are going to find factors until each branch ends at a prime factor. So this will make more sense as we do a couple of examples together. So let's do an example here together. Okay, prime factorization. So if you see here, we start with the number 48. That is our whole number. Okay, that's our whole number there. I'm going to put maybe a box around that one. Okay, to know that that's where I'm starting. Okay, then we have a prime factor tree. Okay, remember we talked about a factor tree up top. Okay, that's how we break down our number into prime factors. So I'm going to make branches is what it says. So it says find a factor pair and draw branches. So this is a factor pair, which means that 48 is divisible by 2 and 24. Okay, 2 times 24 equals 48. So we make little branches and we break it into 2 factors. Well, we know that 2 is a prime number. It is only divisible by 1 and itself, so we are going to circle it. Okay, 24 is not a prime number. It has more than 2 factors, so we can still break it apart. So we're going to break that into a factor pair of maybe 2 and 12. Okay, we know that, again, 2 is prime, so we're going to circle it. 12 is not prime, it is composite. So we're going to still break it apart and find another factor pair. 2 times 6 is 12, or in other words, 12 is divisible by 2 and 6. So we're going to make branches. 2 is prime, 6 is not. So we're going to break it apart again. 6 is divisible by 2 and 3, which are now both prime. Okay, both 2 and 3 are only divisible by 1 and itself. Okay, we make our branches. So we are done with our factor tree. Now it says find factors until each branch ends at a prime factor. Have we done that? Yes, we have. Each branch of the tree ends with a prime factor now. We have 2, 2, 2, 2, and 3. So how we would write that as its prime factorization is we would say, okay, it is 2 to the first, second, third, fourth power. So 2 to the fourth power times 3 equals 48. Okay, or in other words, they wrote it in long form here. Okay, 2 times 2 times 2 times 2 times 3. Okay, very good. Now let's do another one together. Okay, 16. Just for the sake of showing you something different, I'm going to break it apart in another way. Down here it has showed you, okay, that you could break 16 into prime factors until you get all 2's. Okay, and you could do it one by saying 2 and 8. Okay, but you could also break it apart like this. You could break it apart and say, well, 4 is a factor of 16. 4 times 4 equals 16. But 4 and 4 are both still not prime. So I got to make branches off of this one and off of this one. Okay, well, how do I get to 4? Well, 2 times 2 is 4. And 2 times 2 is 4. Okay, notice how I never use the prime factors of the prime numbers 1 or 4. Okay, I know that 1 and 4 will always work for any number. Okay, but I'm never going to use 1 in a factor tree. I'm always going to use something that is 2 or greater. Because remember, 1 is actually not a prime number. Okay, it says whole number greater than 1 with exactly 2 factors. So 1 is not a prime number. We need to get it to its prime factors. So that's what they have written here. 16 equals 2 times 2 times 2 times 2, okay, or 2 to the fourth power is how we would write the prime factorization of that problem. Okay, so now I would like you to pause and try one on your own. Okay, I'm going to give you a problem to pause and try here. I would like you to pause and try the numbers 54, and I would like you to pause and try the number 90. Okay, so you need to first, remember, follow your steps, find a factor pair and draw branches, then circle the prime factors as you find them, and then find factors until each branch ends with a prime factor. Okay, then you are going to write the prime factorization in long form like this, and give me the shortened or abbreviated prime factorization using an exponent. Okay, if you have questions, please come ask. Okay, when you are finished, you need to come check the prime factorization of these two with me at the front, and then you can start your assignment that is in the basket.